Okay, in this video, we are going to discuss parallel and perpendicular lines. So the image I have on the screen currently are two lines that are parallel. So you've probably discussed parallel lines in elementary school math. Parallel lines we can define as lines that never meet. So as much as I zoom out or zoom in, these two lines will never cross, and so they're parallel. We can also think about them having the same angle, the same direction, or using the language of this unit, these lines must have the same slope, otherwise they would eventually meet. So you notice that each of these lines, they're always having the same slope, so one line will never catch up to the other. One way that I can remember the word parallel is that the two L's in parallel are parallel to each other. So you can think about that, you can think about train tracks, or how your feet should be when you're taking a jump shot in basketball. There are lots of ways to think about parallel lines. But for us, that one observation is pretty important, that parallel lines always have the same slope. Because those of these lines are going up 2 over 1, so they're never going to get closer or further away from each other. And you notice that parallel lines have identical slope, so m is the same in both these lines, but they are going to have different y-intercepts. So these lines have different starting points. The blue line has a y-intercept of 1, and the red line has a y-intercept of 3. Lines that have very similar slopes, but a little bit different, are not parallel, even if they don't meet on your graph paper or on the screen. So these lines, the slopes are very similar, 2 and 2.1, but if I zoom out enough, these lines are eventually going to cross. So lines will only be parallel if their slopes are exactly the same. So if I ask you to come up with the equation of a line that has the same slope as this red line, it'd be infinite correct answers. They would just need to include a slope of 2, but they could have any y-intercepts. This purple line has a y-intercept of 0. It's parallel to the red line. Here's a line that has a y-intercept of 5, the black line, and it's parallel to the red line. So there's infinite lines. They're going to be parallel to the red line. They just all have the same slope, but a different y-intercept. So if I asked you to be a bit more specific, and I said, can you find a line that is parallel to the red line and has a y-intercept of -6? Well, we know what slope we need. It's got to be 2. And this needs a b value or a y-intercept of -6. So that might be one question I could ask. And we can also tie this into what we were doing previously. So for example, I'm just going to switch over and do a little bit of algebra. This question asks you to find a line parallel to y equals -2/3 x plus 4. And the only other thing we know is that it goes through the point 3, 8. So whenever I'm trying to find the equation of a line, I like to start with my target. So eventually I'm going to find this target y equals mx plus b. And what do I know so far? Well, I know it's parallel to this line that's given to me in the problem. So I know that its slope, and we can say m parallel, so I'm using these two parallel lines just to say at the label, the parallel slope has to be the exact same. So my slope is going to be -2/3. So I can plug that in for m. So I'm going to have y equals -2/3 x plus b. So we still need to know our value for b. So I can plug in this other point because I have an x and a y coordinate. I've got x equals 3 and y equals 8. So I'm going to replace y with 8, and I'm going to replace x with 3. And now I have an algebra equation that I can solve for b. So I've got 8 equals, and here I've got -2 times 3, so it's going to be -6 over 3 plus b. I'm going to continue over here. I don't have space to keep going down my page. -6 over 3 simplifies to -2. And when I move the -2 to the other side, it becomes a +2. So I've got 8 plus 2 equals b. So b equals 10. And so my final step, now I know m and b, so I can write out the equation of my line is y equals -2/3 x plus 10. So that's the equation of the line that is parallel to my original line, and it goes through this point 3, 8. That's really about as hard as it can get when we're working with parallel lines. The main observation is that parallel lines all have the same slope. The second type of lines that we're going to talk about in this video are perpendicular lines. So lines that are perpendicular are lines that meet at a 90-degree or a right angle. You can think about most intersections are streets that are perpendicular. So if you think about in downtown London, if I have, King Street meeting Adelaide, or if I have Oxford meeting Wonderland, those sort of traditional intersections are always of perpendicular lines or perpendicular streets. So let's see if we can make an equation of a line that's perpendicular to y equals 2x plus 3. Well, I want the line to be going in the other direction. So I'm going to change the slope from positive to negative, but it's still not perpendicular. You notice that there's definitely not 90-degree angles here. This angle on the left is greater than 90. It's obtuse. This angle is smaller than 90. So I also need to make sure that I'm inverting or switching the rise and the run, because these lines really need to have opposite slopes. They need to travel in opposite directions. So if my original red line had a rise of 2 and a run of 1, I want to reverse that or take the reciprocal. So instead of 2 over 1, it's going to be 1 over 2. And notice now I have two lines that are perpendicular. They meet at 90 degrees because their slopes are what we call negative reciprocals. So I need to always change the sign and also flip the denominator and the numerator of my fraction. So the reciprocal of 2 is 1/2. Let's look at another example. If I have the line, negative 1/3 x, the perpendicular line to that is going to have the slope that is a negative reciprocal. So my negative is going to become a positive, and the reciprocal of 1/3 would be 3 over 1. So the line 3x will be perpendicular to the original red line. And there's infinite lines that are perpendicular to the red line, right? Any line that has that same slope is going to be perpendicular. It could have the same y-intercept, but it also could have any other y-intercept. All of these lines that I'm adding are perpendicular to the original line. So as long as the slopes are negative reciprocals, then the line is perpendicular. So perpendicular and parallel, the key parameter, the key thing that we're looking at is the slope. If the slope is the same, it's parallel. If it's a negative reciprocal, then it's perpendicular. And we can do similar math questions. So for example, let's see if we can find the equation of the line that is perpendicular to the red line, but has a y-intercept of positive 4. So if it's perpendicular, I need to take the negative reciprocal. So I flip the fraction and I change the sign. For the y-intercept of 4, then my b value needs to be positive 4. So sure enough, my blue line is the negative reciprocal, the slope. So it's perpendicular, and it has a y-intercept of 4. And again, we can do a little bit more algebra. So this question is asking us to find a line perpendicular to the line y equals negative 2x plus 1, and it needs an x-intercept of 9. So again, I like to start with my target. Eventually, I want to have an equation in the form y equals mx plus b, but I need to find out what is m and what is b. Well, if it's perpendicular to the original line, then the slope of this new line is going to be the perpendicular slope. So I use this little upside down t just as a symbol to me that means perpendicular. It shows two lines meeting at 90 degrees. What's the negative reciprocal of negative 2? Well, first of all, it's going to be positive, and the reciprocal of 2 is 1 over 2, right? So I'm flipping the fraction. I'm changing the numerator and denominator. So the equation of my new line is going to have a slope of positive 1/2 x plus b. And so all we need to now do is solve for b. So I just need to know any point on this line. And of course, the x-intercept is a point. The x-intercept is where we cross the x-axis, which happens when x is 9 and y is 0. So I'm going to put 0 in for y. And I'm going to plug in 9 for x. And now we can solve for b. So 1/2 times 9 is 9/2. And then to solve for b, I'm going to move the 9/2 onto the other side. So b would be equal to negative 9/2. You could say negative 4.5. Then again, my final step is just write out that equation. Y equals 1/2 x minus 9/2. So let's check if we're right. So what I'm going to do is I'm going to go into Desmos, and I'm going to graph the original line, which was negative 2x plus 1. And our goal in that problem was algebraically to find the equation of a line that's perpendicular to that and should cross the x-axis at positive 9. It has an x-intercept of positive 9. And we, through our algebra, discovered that we think that's 1/2 x minus 9/2. And sure enough, we can see visually that this is perpendicular. We have right angles at the intersection point. And then sure enough, it has an x-intercept of 9, 0. So those will be similar to your homework questions and your assignment questions for this activity, U4A6. You'll be working with parallel and perpendicular lines. And really that key insight is that parallel lines have identical slopes and perpendicular lines have slopes that are negative reciprocals. So work through that. Take your time because it can be a little bit tricky, and please email me if you have any questions. Okay, thanks for watching.